All right, so I did 9 of this nice little color right here. I did 16 of this little color right here. 1, 2, 3, 4, 5, 6. You do not have to write this in. I'm just making a point. However you decided to color your 9 and your 16 boxes is up to you. Everybody understand that? Because mine over there is colored a whole lot different. That means you can color whatever color you want, as long as only 9 of them are one color and 16 are the other. I'll tell you right now, I'm going to color it differently for 3rd, 4th, 5th, 6th, and 7th periods. So, however you want to color it, that's up to you. All right. Where is C? Top right triangle, where is C? Let's say the triangle that's not labeled, where's C?
Across from the right.
Very good. So, draw your arrow, mark it as C. Your legs, that means your other 2 sides, they're the ones who form the right angle. They do not matter what color you choose. Or color. Here, I'm still on colors. They don't matter which one you label what. If you want to label one as A and one as B, or if you want to label one as A and one as B, it does not matter. Me, I like to keep my A on the left and my B on the right, but that's just me. I may change as we go. So where you label your A and B do not matter. However, your C always matters. You have to have C in a specific spot. This theorem only works on right triangles. It only works on right triangles. Now, hopefully everybody's got the calculator. First thing we're going to do, we're going to draw a picture. It's not a very big picture, but we are going to draw a picture. We're going to draw in our nice little right triangle. And we're going to go ahead and fill it in. So it tells us what? What's your legs?
6 meters
Each. So where is this 6 is going? Does it go across from the right angle?
No.
No. That's your C. Because we're finding the hypotenuse. So that means this is a 6 and this is a 6. Everybody good with that? I want you to start with the formula. If you do not start with the formula, you're going to have a cranky math teacher. Why am I making you start with the formula? That way you label it correctly. So A squared plus B squared equals C squared. That's where I want you to be first. Now, it tells us is we're supposed to go to the nearest tenth. So, I'm going to fill in my A and I'm going to fill in my B, and I don't know my C. Is everybody okay here so far? A is squared, which means I've got to square my other numbers. Any questions up to here so far? You should not be working any kind of calculator at all. You should just be writing stuff down. Now, from here, I can't exactly put this into an equation, correct? Which means it's there as an equation, but I got to simplify it down. So what is 6 squared? Now you can have your calculators out.
36.
All right, and what is 36 plus 36?
72.
Now, is this my answer?
No.
No, because I want to know what is C. So how do I find out what is C? Ooh, I'm hearing a whole lot, a couple different answers. What if I told y'all you're neither one of y'all are right? What if I cannot add, subtract, multiply, or divide? What do I do?
Nothing.
Untrue. I do something. And we talked about it yesterday, the fact that y'all have this on your calculator versus other people didn't.
Would we subtract?
Can't do any adding, subtracting, multiplying, or dividing. So throw that out the window right now.
Squared.
It's already squared.
You put it in a square root.
There we go. That means I've got to take the square root of both the 72 and the C, because this C right here, go ahead and draw an arrow and make a note that this is C times C. That's how we get C squared. Gentlemen, I need your arms out of your shirts. Wear them normal. Sorry it's cold in here. It's always cold in here. Bring a jacket. So what is the square root of 72?
8.482.
Now, we're doing nearest tenth, so which is what?
8.4.
I'm hearing two? Two of y'all? I don't hear a whole lot of more of y'all. Okay. All right. Any questions? All right. Let's go to example 2. So, what do I want to do first?
Find the right label.
Label.
Yeah.
So, what is 13? C. Now, from here, it does not matter if you choose A and B or whichever you choose. I just put my A on the left. That's just a personal preference. If you always want to put your A on the bottom, put your A on the bottom.
Miss Garrett, is the long side always the C?
Long side is always C. No matter what, no ifs, no ands, no buts. All right, from here, start with your formula. All right, now fill in your formula. Square the necessary stuff. Put in your nice little stuff. Okay. Can I simplify x squared? Do I know what x squared is? Do I have a number to simplify x squared? No, so I'm going to just leave it as x squared. What is 8 squared?
64.
64. What's 13 squared?
116.
All right, now, what do I do? How do I solve this? What's my first steps?
Subtract.
Okay, how'd y'all know to subtract? Did y'all do this or this? A reminder, this is just an equation. I want y'all to get in the habit of boxing your variable. That way you're not trying to mess with your box. Now I'm left with x squared is equal to 105. Is that my answer?
No.
So what do I do now?
Square root.
Square root. That way I'm left with just 1x, and that equals what?
10.2.
Any questions? All right. All right. What are A and B again? Very nice. They're legs. And I'm going to call it leg lengths. All right, what's C? It is the longest side, but what's it called? Hypotenuse. Now, yes, we're going to go ahead and put a nice little thing that says always the longest side. All right, any questions up to here? Fairly simple. Anybody need more time? Once you're done, flip your page. Reminder, I am doing journal tests, which means if your journal is not up to date, you'll probably want to get onto a nice little Google Classroom and get it up to date. All right, anybody need more time on this? What happened there? Sorry. All right. So we were working on a little this late yesterday. Side lengths, 8 centimeters, 10 centimeters, 16 centimeters. So let's go ahead and label these lengths. Which one is your longest? 16. Is that C? The other ones don't really matter. So what do y'all think? Just looking at it, do you think this is a right triangle?
Yes. Yeah.
All right, let's see if we're right.
No.
Well, let's see if you're right. So A squared plus B squared equals C squared. So that's 8 squared plus 10 squared is equal to 16 squared. All right, what is 8 squared?
64.
And 10 squared?
100.
And 16?
256.
So 164, is that equal to 256? So that means that this answer is no. That is not a right triangle. This is what we call solving with the converse. That means we're using this to do something a little different. That makes sense so far?
Yeah.
All right, anytime you see a picture, always label. So, where is your C?
Oh, 11. This one. This one. The missing one?
The where?
This one.
The little diagonal? Remember, it is always directly across. Now, I can fill in the rest of my numbers. Is that 11 the one in the middle?
No.
No. So be careful. And then I just put my A on the left, my B in the middle. So now I start with my formula again. A squared plus B squared equals C squared. And I'm going to move this little thing. Maybe I'm not. I'm going to move it over a little bit. Squared. Now I can fill in my numbers. What's A again?
4.
4. What's B?
11.
And then C is my unknown, right? So what is 4 squared?
16.
And 11 squared? 121. And I don't know C squared. So what's 16 plus 121?
137.
Now, is that my answer of C?
No. You have to square root it.
I have to square root it. What is the square root of 137?
11.7.
11.7. Do y'all agree with him? I only heard one person.
Yes. Yes. Yes.
Did you do it in your calculator?
Yes.
So if I was to do a calculator check out of everybody's just saying yes,
No. I'm sorry.
would I find that yes, you did it?
Yes.
Guys, you should be doing this in your calculator. That way you have to practice. All right, so this theorem works both ways. So if a triangle is a right triangle, then guess what? A squared plus B squared equals C squared works. And if A squared plus B squared equals C squared works, then the triangle is a right triangle. Basically, when in doubt, use A squared plus B squared equals C squared. So, how many of y'all realized that there is not a triangle in the bottom?
I did. When I first looked at the page.
All right. So, it's a little bit of history for you. It says, although Pythagoras is credited with the first proof of the Pythagorean theorem used in Euclidean geometry, it is believed that Babylonian, Mesopotamian, Chinese, and Indian mathematicians understood the concept before his time. That means long before 2500 BC. Now, there are many proofs of the Pythagorean theorem, including algebraic and geometric proofs. Now, unfortunately, we are out of time. So that means this is where we will start tomorrow.